Alright guys, we continue on with section 2.4 in unit 2 here of pre-calculus. We're going to talk about average rate of change. It's pretty much what section 2.4 is all about. It's going to remind you of some things that you guys have learned in previous classes. So if we're thinking of average rate of change or rate of change in general for a function, and a function can be represented by a graph, I think there's going to be a word that comes back in play that you're very familiar with when we talk about this. So we're just going to jump right in with the definition. The average rate of change for a function f of x between. Now remember, if we're getting a rate of change, we need a comparison. So we're going to have basically two values here, two x values between x equals a, where a is just a real number, and x equals b is f of b minus f of a all over b minus a. Okay? So that is our function definition for average rate of change. Now let's almost work backwards to another class, okay? The first time you guys learned f of x, a teacher probably told you that really, when we're looking at a graph, f of x is very synonymous with y, okay? So if we think of the top of this fraction as kind of the y values, because f of x on a graph is representative of a y coordinate, okay? And then we have x equals a and b and a are down here, so these kind of represent your x's. This really should remind you of the change in y over the change in x, which really should remind you of y2 minus y1 over x2 minus x1, which really should remind you of the word slope. Okay? Of the word slope. So yeah, average rate of change in function form or in function notation looks like this, but average rate of change in theory is very similar to slope, but now we're thinking of any type of function. We're not just thinking about a line, and slope is used with linear graphs, linear functions. Okay, so we'll see how slope is represented from a graph. So I'm going to draw a graph right here. All right. We're going to talk about it. So, we could just use slope if all of the functions we were talking about were linear, but we want to talk about average rate of change for any type of function, between 2 points on any function. So if we drew just something like this, okay, and we pick out 2 points that we want to know the average rate of change between. So let's, I don't know, we'll put, A here, and maybe we'll put B right here, okay? And between these 2 points, there is an average rate of change. It's basically how much do we increase or decrease in our y value or our f of x value for however many we're going in the x value. The change in y over the change in x, okay? So if I wanted to know that, the way slope kind of comes into play is, if you guys remember, if we draw a line that intersects a graph at 2 points, we would call that a secant, okay? Or we could call it a secant line. A line that intersects another function at 2 points, or 2 specific points here, like at x equals a and x equals b, we'd call that a secant line. The average rate of change is also this, but also we could define it as the slope of the secant line intersecting the graph at the points a, comma, f of a and b, comma, f of b. Right. So we talk about in algebraic representation, a formulaic representation of the average rate of change, but also kind of show you what it really means on a graph, okay? And the slope of a secant line, we'll talk a little bit more as the time comes, as it's going to lead us into this Newton's difference quotient, which we'll get to right now, and also a calculus topic that we'll do a little group activity on during class this week. Okay, so let's talk about Newton's difference quotient. Okay, and we'll lead in maybe to our calculus topic. Okay, you guys have seen that f of a plus h minus f of a all over a plus h minus a. Okay, so here comes a graph. And again, same type of thing. Okay, we'll draw a curve. Draw the curve looking somewhat like this. Okay, so let's talk average rate of change again. We'll do a similar thing to what we did here. We're going to put a point here, and we're going to call this point a comma f of a. Okay, and we're going to call this point here. Okay. We're going to talk about the difference between these points as the variable h. So from here to here will be a distance of h, making this x value a plus h. Okay? Making this point a plus h, comma f of a plus h. All right, now, you guys may have been wondering for a while now, why are we doing f of a plus h minus f of a all over h? Okay, we talked about it a little bit in our first set of video notes where it's going to lead into a calculus topic called the derivative, okay, and it will. All right, if we were to use our average rate of change formula here, where this is b and this is a, so at x equals a and at x equals a plus h. If we were to find the average rate of change, or the slope of the secant line connecting these two, let's see what happens. All right, so we have our second point. We have f of a plus h minus f of a all over a plus h minus a. All right, basically y2 minus y1 over x2 minus x1. This is also representative of the slope of the secant line, just like it was previously. What happens to the a's here? They cancel. This is called the Newton's difference quotient. Okay? It's a generic way of thinking of the average rate of change. Okay, mathematicians are always thinking of how can we generalize things, because if we can't make sure it's true for everything, if we can't provide a formula that's true for all situations, it wouldn't be as powerful. Okay, so this is the Newton's difference quotient. It's not gonna, we work the algebraic side of this. You guys have been quizzed on your ability to use algebra, simplify, etc. When you get to calculus, this is going to be a little bit more meaningful to you when we start talking about the derivative. But I wanted to show you that as long as we call the difference between these two, that h value, then the average rate of change of these 2 points can be represented by Newton's difference quotient. Okay. And then in class, we're going to do something where we get a little bit even closer to a calculus topic. All right. Most important thing of our set of notes here is understanding average rate of change and being able to find the average rate of change of a function between 2 x values. Okay. If these had numbers, if this was a 3 and this was a 7, this was -1, this was 8, we'd be able to plug those numbers in to this formula and find the actual average rate of change. We'll do plenty of examples like that in class.